Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is statics integration. Right, so I have marked several quiz and some of you I think have it understood already how to deal with integration, but some of you seems to be very much still troubled with regard to integration, in particular for chapter 9 and chapter 10, and the exam is just around the corner. So I think I need to do some explanation. Hopefully it will help in this final stretch of your preparation. Right, so I have made a video before about integration, hoping that you understand the concept of integration and then know how to apply it for chapter 9 and chapter 10. Unfortunately, I think not everyone can get from the concept understanding getting into application of solving problems. So in this video, I hope to just straight away go into the several aspects of application that might be needed in the final exam, especially with regard to chapter 9 to chapter 10, calculation of centroid or moment of inertia using integration. Right, so I think that's where integration most likely to come up in the final exam question. Hence, this video is hopefully just to make you more prepared for those kind of questions, right? For those who have already understood about integration, how to apply, inshallah you are okay, but this is hopefully to help those who are struggling to understand some of the things with regard to integration. All right. So in terms of integration application in statics, in specifically chapter 9 and chapter 10, the equations are as follows, right? So in terms of centroid, you have x bar equal to integration of x with dA over integration of dA, and okay, is this enough space? Hopefully it is enough. Okay, number one, we'll put it down here. Integration of y with dA over integration of dA. Right, so this is the two equation that you have to know if you need to integrate to compute for centroid. This is to calculate for x coordinate of the centroid, y coordinate of the centroid. Now, this is chapter 9. For chapter 10, you have a different equation for moment of inertia. Right, so for moment of inertia, we have I x equal to integration of y square dA. Remember, for centroid, it doesn't matter which element you are using, the equation is still the same. For example, for where to write it? Okay, never mind, we'll talk about that later. We'll just list the equation first, right? And then you'll have Iy equal to integration of x square dA. Right, so this is the four equation where you might need to integrate, right? Of course, there's another two equation. I'll just write it down also. So you have Ix equal to integration of dIx and Iy integration of diy. So basically, these are the six equations that you may need to use when you need to integrate to find either the centroid or moment of inertia in x-axis, or about x-axis and about y-axis, right? Now, the difference between these two, I'll use the red one, between these two equations, because it is finding both moment of inertia about x the same, moment of inertia about y the same, is that for this one, it is for this element here, and this one for this element over here, while this one is for the other element, right? Right, so you cannot mix, meaning that for Ix, if you want to use a horizontal element, then this equation is valid. But if you want to use this element, you must use this equation. If you use this element and this equation, that is wrong. Similarly for Iy, if you want to use this element, this is the equation. But if you want to use this element, this is the equation, right? So we have to divide that so that it is not So how to do this? So you have basically 4 separate cases there, right? So there are explanation there in the lecture. I have explained how to understand this, but if this is already near the final exam, one way is just memorize, right? So because this particular video is just for those who are, you know, struggling, need help, final stretch, you can just memorize. Okay, but it's not that good to memorize, because if you understand, you can always recall how to understand it. Basically this one is parallel to x-axis, this is parallel to y-axis. Go back to the lecture, we discuss more on that. For this case, it doesn't matter, right? For both equation, you can use either horizontal as well as vertical, not a problem. Alright, so that is with regard to element as well as equation. Now, how to apply, right? How to apply. So several things that you have to understand in terms of the difference. One, make sure you have the equation correct. Do not mix up between moment of inertia and centroid. So memorize the equation. Second, understand or at least memorize which element can be used for which equation. Now, after you have done that, after you know that already, I'll keep this here. So our space for calculation is quite limited here, but we'll try. The effect of the element, okay, for all of this equation except for this one, we will forget about this one. For this video, we will just focus between this and this, right? Between all of this, you will notice that there are dA that is in all of the equation. What does dA mean? Okay, which one is better? dA is just area of the element, right? Simply, dA is the area of the element, meaning that if this element, then it's the area of this element. If this element is the area of that element, right? So how to find the area of the element is simply just, because this is basically rectangular. So if I'm using, right? Okay, one thing that by now I hope you already understand, when you have this one, this is dy, because that is the y thickness of the element. This one is dx. So hopefully I do not need to elaborate on that. That should be clear, right? Is it clear? I hope the lighting is not disturbing too much. Alright, so that is clear. What about this? So we are focusing on this length now, right? This length or this length. Now I use L for now, because some of you are confused about x or y or what minus what, etc., right? But if you use L, the length for now, the length be it that way or this way, the area is simply just, in this case, dA is simply just the length times the height, which is dy, right? In this case, dA is simply the length times the width, dx, right? So that should be straightforward, right? However, in application, this L sometimes I notice produce some confusion to some students. L is actually length, right? Length. Now, when you deal with x or y or x wave or y wave or x bar or y bar, understand that all of these are coordinates. I repeat, all of these are coordinates, x coordinate and y coordinate. So when you write like this, x, y is the x coordinate, y coordinate. X and y is never a length, it is a coordinate, right? So, okay, lights are there, right? So, if there's a point there with x, y, it is the coordinate. Of course, we understand, okay, this is x and this is y, right? So that x and y is with respect to the length from the origin. Hopefully you understand. So it is quite straightforward if the element is like this. Okay, which color I should use? Okay, I use red, right? If the element is like this, vertical element like that, then obviously this length here coincide with this y, right? So L equal to y. So you can get y dx. But if the element is somewhere else, for example, okay, this is still xy, but I'm drawing it at the element is here. The element is here, right? So now L is here. Is L equal to y? No, right? Because this is y, right? So if we know this value here, then this value minus y is that L, right? So hopefully you understand. So L is not always y. Y is not the length. Y is a coordinate, right? This coordinate meaning this is y. So when I want to find this L is not y in this case. It is something minus y. Is the difference, right? So in this case, just to make it easy for this particular, if you just want to memorize, this will be, I make it in a generic form, y2 minus y1, whereby this is y2, this is y1. Okay, is it light? The light is okay. Again, just to repeat, I make it in a generic form, y2 minus y1. Now, so if you understand that, if you memorize like that, if we have a curve, okay, this one is not good anymore. So if we have a curve like this, if the area is down here, the shaded area is down there, meaning that the element is here, right? Okay, so just take that y2 and y1. So this is y2, this is y1. y2, y1, right? And because this line is y equal to x, for example, or y equal to something x, mx, for example, whatever the function is. So y2 becomes y. So in this case, y2 becomes y, because this is y equal to something. y1 equal to 0. Hence, you get y minus 0 equal to y. So the area becomes y dx. But if the area is, if I'm redrawing it back again, if the area is up here, this is the area, so then y2 is here, y1 is here, right? Based on that generic y2 and y1. So in this case, y1 is y, right? y2 is whatever value here. Let's say this is 10. So then y2 is 10 because it's a constant 10, right? So then it becomes 10 minus y, right? So hopefully you understand when I put it in a generic way like that. y2 minus y1. It's always y2 minus y1. y2 is on the top part, y1 is on the bottom one. So which one is y, the curve? Which one is whatever number, be it is some number or 0? You just plug in. Sometimes the curve is like this, meaning there's two curves, right? So the element will be like this. In this case, you actually have two functions. This one function, this two function. Then it exactly becomes y2 minus y1 because y2 has its own function, y1 has its own function. So it doesn't have any static value like 0 or something, right? So it becomes this minus this. So as long as you understand, okay, L is always y2 minus y1, so you are safe, right? Be it if it's on the bottom, touching the x-axis, then it will become y. If it's on the other side, it becomes something minus y, or in this case, y2 minus y1. Fine. if you understand this, you can understand this as well, right? So we'll just let it be like, maybe I should use a different color. This is x2, this is x1. So L equal to x2 minus x1, right? L equal to x2 minus x1. So if you have area like this, here is the area, then the element is like this, right? And x2 is here, x1 is here, right? In this case, x2 equal to x, right? Because this is x, y in the function of x. So whatever x is there, right? The function. x1 here equal to 0, because this is where x equal to 0 here, right? So in that case, it will be x minus 0, so it will become x. Hence, L become x, so x dy in this case. In this case. If the same curve, but the area is now changed, right? The same curve, but area now is here. So if you have horizontal element like this, then x2 is here, x1 is here. In this case, x1 is x, right? Because this is the function. So you can find x equal to something in terms of y, for example. And then x2 here is whatever value here. If this is 20, then this equal to 20. So then you get 20 minus x in this case, right? I try to use some number that normally do not come in the exam, so that you understand, okay, where did that number come from? Because I did the example in the previous integration video, where this is 1, and then 1 minus x, and then suddenly when the quiz come, this number is 2 or 3, you still make 1 minus x. So that means you do not understand what that 1 means. It's not an equation. It's not 1 minus x. It's actually what x2 here equal to what? Minus x. Right? So in this case, I put 20. Hopefully, you will never put 20 there, because it should be obvious that this 20 come from here. Alright? So it will be like that. So if you have another type of curve, for example like this, then if you have horizontal element like this, so if this is x2, this is x1, then obviously it will become x2 minus x1. Now take note that, of course, if you have array like this, you have to stick to one kind of numbering. Let me use A and B for this case, right? A and B. For example, if I say this curve is curve A, this curve is curve B, right? Why I'm showing this? Because number 1 and number 2, based on this and this, will change for horizontal and vertical. What I mean by that is, if you use horizontal, x2 minus x1, right? If you use vertical, suddenly y2 and y1. So this line for this one is 1, for this one is 2. This line for this one is 1, for this one is 2. So that's why I put A and B here, so that when you go here, if I label this A and B, for x, x2 minus x1, meaning xb minus xa, right? So xb minus xa. But for y, y2 minus y1 is ya, this is a, right? Ya minus yb. So you get ya minus yb. Okay. So hopefully you understand now, because if from the starting point you make a mistake in terms of dA, because all of these equations have dA. So if your dA is out, whatever you calculate after that is just out. So do not make a mistake there. So hopefully you understand by now. This length is a length. So it is something minus something, right? No, sometimes it is x minus 0, sometimes y minus 0. Hence you get x or y. But it's not always x, it's not always y, because x and y is just coordinate, right? So I'm trying to put it in a different way so that you understand what is actually happening before you get x or y, or something minus x, something minus y. It's basically just x2, y1, x2 minus x1, y2 minus y1. Alright, so that is for dA. So for dA is okay, for dA is okay. Now, going into this, xy, x wave, y wave. Right, hopefully this about the element, the dA of the element is fine now. Moving to, in this equation you have x and y. Right, you have x and y. In this equation you have x wave, y wave. X wave, y wave. Right, and obviously this one is x bar, y bar. All of this have its own meaning. Do not mix it up. Do not mix them up. Because if you randomly write, that's wrong. What this means, okay, for this one, what this means, okay, is it, can you see from that one? Okay, hopefully you can see that. This one is just any point on the curve, right? For example, there's a curve here. So any point you take here, so just generally I just put one point there. The coordinate will be x, y, right? So that's why when you have element here, for example, you have y minus 0, because that y is the coordinate there. This x wave, y wave is for the element. For the element, meaning that when you have this element, this is x wave, y wave. Alright, if you have this element, the center here is x wave, y wave. Alright, that's the meaning. We discussed on the meaning first before what is the implication to our calculation. What about x bar, y bar? X, y bar is basically this one. What you normally want to calculate, which is the centroid of the whole area. So meaning that if you have whatever area here, then the centroid of the area itself is x bar, y bar, which is what we want to calculate for the area, right? Be it this or wherever. Okay, so we will not discuss about this because this is what we calculate anyway. We will discuss about this because when it is on, okay, hopefully, okay, one by one. Hopefully this one is clear, x and y. So, because of this, and it is related to the curve, and the curve never change, the curve is what the curve is given by the question, then this x and y do not change anything. Right, when it is x, then it is x. Move on. Okay, so, do not change, meaning that you do not have to change the equation. When you just find what is dA, and then you just plug in, and then you are ready to integrate, be it with respect to x or y, right? So this straightway is directly related to the function. When you have y equal to mx plus c, that y and x is this y and x. All right, so that is fine. No need to think too much about that. X bar, y bar, that's also fine because that is what we calculate anyway. So no need to discuss here. Okay, for the element, this and this. This is where, again, I repeat, if you still remember from the beginning, x, y, x wave, y wave, x bar, y bar, coordinate, right? So the coordinate is always with respect to the origin and xy axis, right? So if this is coordinate, so x, y, right? So if we have a certain element here, right? Let's say we have a certain element there, and then that is the element, for example. If we have the area here, the centroid there, meaning that this is my x wave, y wave coordinate, right? Now, meaning that this is my x wave, correct? And then this is my y wave, the coordinate. Simple, right? How to calculate it then is, when you have this, Remember, right? For example, in this case, because how come this is area like this? For example, if the curve is like this, for example, there's a curve like this, and then here, right? For example, this is the area. Hence, that is the element, right? So, in that scenario, the x and y, on the curve is here, right? That is x, y. With meaning what? Meaning, what color is left? Okay, so x coincidentally is here, right? Is the same, and y is here. This is y. Okay, my marker is right. So that's why you get x width equal to x, x width equal to x, because it's basically the same length. But y width, then for example, if here you have 10, right? If this is 10. So this is where you have to find what is this y width, which is the center of the element, that the two, meaning that y2 and y1, if you refer back to the, if you have the here y2 and y1, right? Okay, generally speaking, if we focus on here, what is y width when y2 and y1 here, right? Generally speaking, whatever value this one is. What is y width when y width is at the middle center of the two? Meaning that this value and this value, the middle is the average, right? Hopefully you understand that concept. If you have some value, the middle is the average between the two. The average between the two is the middle, right? So average is simply, y width is, average is this plus this minus 2. Divide by 2, sorry. y1 plus y2 over 2. That's average, right? So to make it simple, just memorize this. This one, because it's the middle between this value, whatever value, wherever the axis is, maybe 10, maybe 20, maybe 0, whatever value is, for sure this is the average between this and this. So just take it, this is the average. If in this case, y1 is y, y2 is 10, right? For this special case, 10 and y. So then it will become y plus 10 over 2, right? That is if that is the case. If it is something else, then it is something else. If, for example, it's not like this, it's not a constant 10, it is, for example, let's assume the question is something else, which is like this, right? Can you imagine this? Meaning the area is within that two curve. Then y2 is with respect to this curve, y1 is with respect to this curve. So it will valid anywhere, right? Just as long as you understand it is the average between these two value, whatever value that is, right? So sometimes this can be y, this can be 0, sometimes this can be y, this can be whatever value, sometimes this is function, this is function, meaning y2 and y1. Similarly with this one, this element, right? So if you put this as your x1 and this is as your x2, right? So we erase all of this first, right? This is your x1, this is your x2. X wave is at the middle, okay? Whatever value, it is at the middle. So it is essentially the average between the two, right? Whatever value, you take the average, it becomes the middle. So then x wave is x1 plus x2 over 2. Or you can also put x2 plus x1. And sometimes I do prefer that one. Okay, let me rewrite. Y wave is y2 plus y1 over 2. Why do I prefer this one than this one? It's the same, right? But because when you have the in the calculation later on, sometimes it's become like this: y2 plus y1, y2 minus y1. Right, so it's easier. Oh, a plus b, a minus b become a square minus b square, right? If you remember your mathematics. So that's why I arranged that way. Because if you arrange this one, y1 plus y2, and then y2 minus y1, so it's I have to multiply or whatever, right? So I prefer just like this, or here x wave is x2 plus x1 over 2, right? So sometimes it becomes x2 plus x2 plus x1 over 2, and then when you plug in, because for dA just now, you remember dA, it will come x2 minus x1, right? Or y2 minus y1. So that's why when, for example, right? For example here, right? Okay, this is straight away giving an example. When you have in your integration, you have x, all my marker is gone. Okay, you have x wave and then you have dA. I'm just taking this element there. In dA, if you remember before, you have L, right? So if you focus here, L is what? dA when L is basically x2 minus x1. So that's why in this dA, sometimes you have x2 minus x2 minus x1 and then dy, because this is dy, right? If this is the element, for example. So in x wave, that's why I like to use this x2 plus x1. So x2 plus x1 over 2. So that when I want to solve, x2 plus x1, x2 minus x1. So down here, x2 square minus x1 square, right? That's just preference. It's not compulsory. It's just I'm too lazy to make too many steps. So I like to simplify from the beginning if I can. Anyway, as long as you can understand, right? So the meaning is what? Average. Average. So just memorize that. So if x1 becomes x, x2 becomes 0, then it's just as it is. If, for example, right? The normal case that sometimes we calculate is something like this, right? Like this, right? It touch the, so when you have y2 and y1 here, when the curve is here, so obviously y2 equal to y. In this case, y1 becomes 0. So that's why, so y wave, it become y over 2. It's here, right? Y wave. So, if you just memorize, let me go back to my proposition to you, especially for those who struggle to understand the concept, etc. If you just memorize, the concept is average, you just use this one, right? So you have y wave is y2 plus y1 over 2 in your mind, in the concept, right? So this is y2, this is y1. In this case, y2 is y, so you get y, y1 is 0, plus 0, then divide by 2. Hence you get y over 2, right? That is from just memorizing this or this, right? Of course, for those who understand, this is y, right? This is halfway through, it's the middle, so obviously y over 2. So either way, you have the correct answer, inshallah. So again, as I mentioned at the beginning of the video, this video is directed towards those who just want to memorize something. So I'm proposing this and this, so that you will still get your correct answer, even if you confuse still what does it mean, etc. Understand just y2, y1, y2 plus y1 over 2, average. Alright? So then that is settled. The other thing, the final thing is limit, because when you want to integrate, there's a limit there, right? So by now, I have explained about dA, x and y is okay, x wave, y wave, hopefully you understand. Now, what about the limit? Because when you integrate, something is here, right? Not 0. Okay. How to put something? Something here, right? A certain number. That is the limit of the integration, right? Now, where does this limit come from? It is from the element, either that one or this one. This is just to simplify, right? It comes from the element. It's not because x or y or ix or ry or is or iy. No, it is because of the element. So meaning that if you use this element and this element and this element, the horizontal element, the limit will be the same. If you use vertical, vertical and vertical, the limit will be the same for the same area. What I mean by that is, say you have this area, right, down here. If you use, okay, what color is good? If we use horizontal, right, this way. Now, the limit will be, the first element is here, right? The last element is here. So the limit will be from here to here. So from 0 to something in this case, right? So that's how you understand it. It is based on the element. If, okay, still about the, how to say, still about the limit using horizontal. So if in this case, for example, the area is different, meaning here is the area here, the area here, right? If you use horizontal element, the first element is here, the last element is here, right? So it's from here to here. Coincidentally, it's the same in this case. So it's not about, so it's about the element where it starts, where it finishes, right? So that is for horizontal. So similarly, if you have, like for example, area in that way, right? So if you take horizontal element, first element is here, last element is here. So from here to here, right? So again, whatever the shape, whatever equation, as long as the element like this, then it is from the first element to the last element, like that. Fine. What about vertical? So if it's a vertical, okay, so all the color are already, I need a new marker. So if it is vertical, so let's start with this area. If it's vertical, so this is a sample, right? So where is the first element? Here. Where is the last element? Here. So it is from here to here, the limit, right? Same, if you have area like this, here, right? So first element, last element, right? Of course, I'm magnifying it so you understand. So from here to here. Similarly, if it is inside here, right? So if this is the element, so from here to here, right? So it is not about, oh, I'm finding Ix or Iy. No. If you find Ix, if you use this element, it's from there to there. If you use Ix to find this element, it's from there to there. That's how you understand the limit, right? If I find Iy, if I use vertical element, it's from here to here. Horizontal, from here to here, right? Similarly here. Of course, all here I'm showing where the element starts from 0. So let's okay. If we have, just to be safe, just to show if the limit do not start from 0, right? For example, if you have curve like this, but the area the question gives is here, meaning here it doesn't consider, right? For example, like this, right? So in this case, if you have vertical element, so the first element is here, the last element here, right? So the limit for the integration is from here to here, right? So hopefully you get the drill by now. You understand? Oh, okay. So this is the area because this is outside of the area also, right? If okay, I'm rushing here. If the axis is like this and somehow the area is like this, right? And it's covered here, right? So meaning that maybe it can start from negative something here to something here, regardless, whichever it covers, right? So this is example for vertical. Same concept applies for horizontal element, right? From where to where. So now you have understood dA, you have understood x and y, you have understood x wave and y wave, and also you understood what limit you should put here and here, here and here, all this limit, right? Is from here to here or whatever that we have just discussed. Alright, hopefully this helped you to prepare for specifically chapter 9 and chapter 10. We covered simultaneously because Integration is integration. What different between chapter 9 and chapter 10 is the concept that we are covering and what we are calculating, right? Centroid, moment of inertia. And memorize properly the equation, do not mix up, do not change whatever, and understand. So I repeat, know the equation, know which equation can be used with which element. This must be with this, this must be with this, this must be with this, this must be with this. This one is free, whichever, same answer. And then know the implication in terms of dA, in terms of x wave, y wave, and the limits. With that, inshallah, hopefully it helps for you to prepare. And wallahu alam, we'll end it here. Inshallah, hope it helps. Subhanakallahumma bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.